Welcome to Spring LIB.
All right, because the measurements are made far from the antenna, we can assume this is the same as a uh, double slit experiment. Okay, so this is essentially a double slit with the two antenna acting as the two slits. So the first step is obviously to find the wavelength of the broadcasting signal, which is just speed of light over the frequency. So the speed of light is 3 times 10 to the 8 meters per second, and frequency is 88.5 megahertz, so it's 88.5 times 10 to the 6 hertz, giving us a wavelength of 3.39 meters. Note that this is much higher than the visual wavelengths in the nanometers, so this is in the radio. Okay, so we have two cases, constructive and destructive interference. The maxima will occur in the constructive interference. And so in the case of constructive interference, and I use blue ink here, we have d sine theta, and theta is what we have to find, is equal to m lambda, m being the order. Therefore, theta is just the arc sine of m lambda over d. And so we try out different values of m to see what thetas we get, right? That's the idea here. So for m equals 0, theta naught, or theta 0, we have arc sine of 0. And so that's 0 degrees. Theta 1, you have arc sine of 1 times 3.39 over 9. And so this gives us 22 degrees. For theta 2, arc sine of 2 times 3.39 over 9, this gives us 49 degrees. Now, when we try m equals 3, you have arc sine of 3 times 3.39 over 9. Note that the numerator is greater than the denominator, and which cannot happen. Sine theta cannot take a value of greater than 1, so this is impossible or imaginary. This will give you a math error if you enter it on the calculator, so theta 3 won't happen, and so the maxima will occur at 22 degrees and 49 degrees. And then for the destructive interference, I use red ink here, destructive, the formula is d sine theta equals m plus 1/2 lambda. So therefore, similarly, theta is arc sine of, this time, m plus 1/2 lambda over d. Okay, and so let's again do the same thing of trying out different values of m for the corresponding theta. So theta of 0 gives us arc sine of 0 plus 1/2, so it's 1/2 times 3.39, the wavelength, over 9. By the way, these are both in meters, so don't have to write that down. And so that is 11 degrees. M equals 1, you have arc sine of 3/2 times 3.39 over 9, giving you 34 degrees. Theta 2, which is m equals 2, the third order, you have 5/2 times 3.39 over 9, giving you 70 degrees. Now, when you try m equals 3 here, you have arc sine 7/2, 3.39 over 9. And again, you see that the numerator is greater than the denominator, which cannot happen, which cannot be a real arc sine value, so or real sine theta value. So now you have, and so here you have an impossible situation. So you're limited. The 3 thetas you have are 11 degrees, 34 degrees, and 70 degrees for the minimum.